I'll start by um, tell you that I'm a scientist, and that what do you think scientists are doing? And the main thing they are doing is they are just asking questions. So if you are curious, if you're nosy, then it's a good thing to become a scientist. Um, so we like to ask questions, and I mean, if we ask good questions, then it becomes interesting to many people most of the time. Um, and then when we ask those questions, we want to see if we can have an answer. And sometimes we have to do experiments to figure out if it makes sense, if the question can be verified, or if we make some hypotheses, if they can be verified or not. So we like to find the answer to those questions. And that story of question came in our lab. We were very interested about some kind of a recommendation in a way a long time ago, when you were maybe some of your parents were around, maybe not even. In the 60s, in the early 60s, there was some recommendation that came about diets, what's good. And the recommendation at the time, what's good or not so good. And the main thing about not so good was fat. Fat is really bad. Thank you. And you want to avoid saturated fat. And there was a big campaign to try to take away or reduce the fat consumption. And now we are about 50 years later, and now we say maybe fat is not that bad. Maybe sugar is the problem. So it's kind of interesting to see how those recommendations somehow can have an impact on our decision. And one of the impact that happened with those recommendations is that when they started to recommend that move away from fat, limit fat, don't eat too much fat, one of the consequences that we started to eat a little more sugar, not just carbohydrate, but sugar. And what I'm going to show you today is that the sugar that we wanted, that we used to replace the fat, has been actually, seems to be converted into fat. So our body uses the sugar that we eat to make fat. And so it's some of those controversies, that some of those kind of strange questions, that just go around, and you think you know something and you realize that, maybe you don't know everything. And in science, we often have that kind of issue. So I have a very short kind of summary of the presentation. Hopefully, if the audio works.
So you some answers, Hoss.
What, you feeling chatty all of a sudden?
Sorry, I can't talk right now. I got some secret cases of my own I'm working on.
I hate to tear you away from your video game.
All right, I'm hanging up.
You know the most destructive force in the universe?
Most destructive force of the universe?
Sugar.
Sugar. All right, so that's pretty much the summary of the talk. So some people are asking those questions. So is it really that bad? And so I'm just going to now try to tell you a little more about what we discover. So is soda drinking good for you? What do you think?
No.
Is it good for your liver in particular? Is it good for your liver?
No.
All right. So I guess I don't have to present very much. You may have all the answer. So first I'm going to show you a little bit about different kind of sugar. There is a chemical structure that's different, and because of that, sometimes you have very different effects on the liver in particular. So if you look at that, can I?
Ça marche, ça.
I don't have a pointer. Maybe it's this, huh? What about this one? No.
Non, je crois pas.
So if you look at that structure, the glucose and the fructose, you see there is some ring. One is a 6 carbon, a six molecule, 6 atom ring versus a 5 atom ring with an oxygen in one corner, right? And so it's the glucose versus the fructose. But if actually you count all the carbon and all the hydrogen or everything, it's actually the same number. It's 6 carbon, 12 hydrogen, and 6 oxygen. And it's the same on both things. But because of that shape, that different shape, it's metabolized differently. And so you can find glucose and fructose in both sweets, candy, soda, and stuff like that. But you can find it also in fruits. So one of the questions is, is that always bad, or is it depending on how it is packaged? And so when you have sugar in your tea, you put sugar in your tea. It's sucrose, and sucrose is actually the fructose and the glucose. You can recognize the fructose on the right there, and you can see the glucose on the left, and they are bound together. They have this oxygen that's connect them together, right? So that's the sucrose that you put in your tea or coffee or on syrup. Or maybe you don't drink coffee.
Yeah, I drink
Yeah?
coffee.
Oh, you don't? All right.
Some people drink coffee, some people don't.
Ah. So in the 70s, there is some people who develop a way to make corn, and in the corn you have basically glucose, and they make a way to process that glucose, to convert that glucose to fructose and glucose. And why did they do that? Because fructose is a little sweeter. So it tastes a little sweeter than glucose alone. So by using corn to make this mix of glucose and fructose, they could generate something that's sweeter. And when you want to add it to food, sometimes you want to have a sweeter taste. So that was a big deal in the 70s, and it had a lot of consequences because it becomes very cheap. It was partially subsidized because the corn was subsidized. So the growing corn for farmer was a good deal, a good business, and the industry could have very cheap sugar, and it's still very cheap sugar, and maybe that's one of the problems. And when you think about the consumption, you can see that basically we use less sugar, table sugar, a little less table sugar, but we have this high fructose corn syrup that was built here that just came up over the years between the 70s when they start to invent that. We start to use it a lot, and if you look at all the sweeteners, all the added sugar in our food, it just has increased regularly from the 70s to now, or not quite to now on that slide. On the other side, the industry, and here you have one of the beverage industry, you can see that the size of those drinks, 6.5 ounces in 1915, and look, now we have those big gulp things, 44, and there is even bigger than that now.
The big one.
The big gulp, yes. So that's really a huge size increase, and it's quite a bit of sugar that you have when you drink those things, especially the current size. So what does it do to your body? And if you think about your body, you can see that you ingest, and I'll show you just the digestive tubes and the intestine, and you see that little guy. Oh, I don't know. That little guy is trying to drink that big things, and that drink is going through the gut very quickly, and it gets right there to the liver, and it's like a tsunami. It's like a big wave of sugar that goes to the liver, and that's what tsunami. Do you think tsunami are a good thing or
No.
not so good? In our body, a big wave of tsunami is not good, and we are going to tell you a little bit. And the first question that we wanted to ask is de novo lipogenesis. You know what de novo lipogenesis means?
No.
De novo, it means new, nouveau. It's like making new. Lipo is lipid or fat. Lipo. Genesis is the making, right? Building. So it's making new fat. So are we making fat with sugar? And that's the question we ask. We were starting to wonder if you make fat with sugar. And so the question is, how can you measure that? And there was a method to measure that. In human, it's hard to measure things in human being, because you cannot do things in human that you would do in animals. And there is some animal research that is pretty involved, and that's maybe not so fun for the animals. But in human, you are very limited. And there was one method, and it was just by looking at how much oxygen you breathe and you consume and how much CO2 you produce, we could actually calculate how much sugar to fat was converted. But we could calculate only the tip, only if it was really huge. If there was a huge conversion of sugar to fat, then we could measure that tip of the iceberg there. We actually were missing all that part, the bottom of the iceberg. So what do you think is? What do you think about when you think about iceberg? What do you think about? The tip, yeah.
Ice. A big piece of ice.
A big piece of ice, yeah.
The Titanic.
Hey, here we go. So that big things that you don't see sometimes could have some very bad effects. The Titanic, right? And I think the scientists for many years, they were just looking at the tip of that conversion of sugar to fat, and they were missing the big bulk of it because it was hidden from the type of measurement that was done at the time. So, and we know that the Titanic story didn't finish very well, right? So sometimes when you don't see you just consider just the tip of the story, you can miss something. And with the sugar conversion to fat, there was a big missing story. And that conversion there was a new method that came out. It was not far away from here. It was right there on this campus at UC Berkeley. And somebody, Mark Ellerstein, who is a professor at UC Berkeley, came out with a new approach. He said, well, let's put some tag in the sugar, those little red star. If we put those little tag in the sugar, and if we find those tag into the fat, he find a very fancy way to measure how much sugar was converted to fat. But not just the tip of the iceberg, the full iceberg things. And I came to Berkeley, I'm not going to tell you how long ago, but it's a while ago, because I was very interested to say, oh, this method is very, very interesting. And it could answer that question, because a lot of people started to wonder, you know, is sugar really impacting your fat in your blood? Why is sugar seems to be associated with bad lipid profile, which is bad fat in your blood? And so that method, basically, you can put a tag on the sugar, on the fructose, or into that pathway, and then you can, and that was basically the method from Mark Ellerstein. And I came to do a postdoc in that lab. I was very interested to actually start to work with fructose. And we did the first experiment using very fancy machine. So those tags are carbon 13. What's the normal weight of carbon? Do you have a little bit of chemistry?
Not yet.
Who knows about the weight of a carbon molecule? It's 12. Carbon has a weight of 12, okay? But if you use carbon 13, it has one additional mass. And if you have a very fancy scale, you know, I don't know if you watch CSI or those, you know, show, they use those GCMS, gas chromatograph mass spectrometry. You can actually weigh those. You can have a sample of fat that you put in that little vial, and then you have this automatic sampler, and it just has a needle. It goes into the vial. It takes a little bit of it, and then it injects into that GC, and the GC is a gas chromatograph. It's just a separation of fat, and then the mass spec is the scale, and that scale tells you, wow, there is some additional weight in that fat. That fat is weighing more than a normal fat. So that suggests there was some conversion of sugar to fat. So that method was actually a big deal. It was in the 90s, but it was a big deal because suddenly you could measure the full size of that iceberg. And the first experiment, we did it here in Berkeley and UCSF. We just gave glucose, and this is basically that conversion of sugar to fat, and we see how many percent of the fat in your blood was coming from sugar. And you see that if you give glucose, little drink every half hour from 10 a.m. to 6 p.m., right? People who get glucose, they don't make fat with glucose. However, if you give them fructose, you see that fat, you have 20-25% of the fat in the bloodstream that's coming from glucose, well, from fructose. Okay? So fructose and glucose, you remember the ring of 5 versus the ring of 6, even though they have the same number of carbon and everything, it's metabolized differently, and it's much more conversion to fat. So after that, we wanted to see, but this is a process that's going on in the liver, because when you drink sugar, everything goes to the liver, all the sugar goes to the liver. And the liver, we know that fructose is basically staying in the liver. So if you have so much fructose staying in the liver, if you have this conversion of fructose to fat, does it affect your liver fat? Is it good to have fat in your liver? No, it's not. So how can you measure liver fat? It's in the liver. So the liver, you know, is pretty much inside your body. So how can you measure it? We can use a MRI or MRS, a magnetic resonance spectroscopy, that big machine there, And when you do that, you can see inside your body. And you can see, and here maybe if we could turn off the light a little bit, you can see this is the liver. And then inside the liver, you can take a little bit of a cube, and inside the cube, you can look at how much fat you have there. And by doing this, we did an experiment where we put subject into a magnet, and we look into the liver, and you can see, and it's again a little hard to see maybe, but you see this is the fat in the liver. This is a little peak of fat, and you can see that peak of fat. You see it's the size of my full hand here, and this is the size of 2 finger. Full hands, 2 finger, right? And that's the increase of fat that you see in your liver before or after soda drinking. So you see, you can see it just, by using this methodology, this MRI, MRS technique. So that's what we did. We measure it. So we were very interested to do that. And then the next question that we wanted to ask is that if you have children who really like soda, who really like sugar, and really eat a lot of them, and what would be the benefits, potential benefit? Is it helpful? Is it good to just stop? What do you think? It's good to stop? To stop drinking soda and fructose?
Yeah.
No? You think it's good to continue?
Yes.
Tastes good, right?
No.
All right, so we did an experiment with honey for 9 days. We just take away the fructose from the diet. We just put some more complex. No, it was not like a very, there was bread, there was pasta, which are more complex carbohydrates. So, but there was no simple sugar like the fructose or like the drink or like the things. So we did that for 9 days, and we studied them, and we did a lot of measurement. And this is part of the measurement that we did. And we take a lot of blood sample over the day. And then we measure this conversion of sugar to fat. You remember that de novo lipogenesis. And you see that only 9 days, this is at the beginning of the day, and this is at the end of the day, and this is the first day, and that's the conversion of sugar to fat. And you can see with 9 days of suppression, we have a huge decrease of that conversion of sugar to fat. You see that, right? This is much lower than here. So we were very impressed by that. And actually, we published this paper just last month. And if you quantify with the MRI machine, we quantify also how much fat was in the liver, and you can see we have a significant decrease, a big decrease of liver fat, only in 9 days. And a lot of those children had very, very large amount of fat in their liver. You don't want to have fat in your liver. It's not a good thing. So, and here you can see that almost, we studied 40 kids, and you see almost all of them went down when you do have that fructose restriction. And some had quite a bit of it at the beginning. So just to summarize, 9 days of restriction of fructose was enough to reduce that conversion of sugar to fat. The liver fat went down, and a lot of things that are related to diabetes, like the glucose and the insulin, were much better also with these 9 days. And also all the fat that's connected to cardiovascular disease was reduced. So we had a lot of very significant results. And basically you see, we can see that with fructose, it leads to fatty liver and some problem. And when you start to have a fatty liver, then it's more like a diabetic kind of liver. And I think you did see the
Oh yeah.
So
Be sweet. That's my choice.
so be sweet, but make the right sweet choice. Okay? Yeah.
So we don't drink sweets? So like no soda?
No soda, no juice.
But we
That-
can eat candy?
What about Oreos?
Oh, so there is a very simple thing. If you want to take the, if you don't want to take risk and you want to have a healthy diet, you don't use processed food. If you have sweet processed food, so candy, cookie, drinks, all that is more likely to have this tsunami effect because you have quite a bit. If you have a fruit, it comes with fiber, and that's come out. Instead of having a tsunami, you have just a slow wave of sugar that comes to your liver,
What
and
about
the
like-
liver can handle a small wave.
What about like vitamins and gummies?
Yeah.
One of those. I mean,
Vitamin.
Explain it, doesn't it?
yeah, like
Yeah,
those
dietary
gummies, the
supplement.
vitamin C gummies.
I eat those all the time. I'm not even like supposed to.
So vitamin, vitamin is something we need. And a lot of things have been discovered actually up there in Berkeley. Nutrition department, they did some discoveries a long time ago. That was in the early part of the 1900s. So they are necessary. So vitamin is a different question. It's clearly we need vitamins, and there is some vitamin that's mix well with fat, and they are called the liposoluble, and there are vitamins that mix well with water. They are the hydrosoluble vitamins. So vitamin is important, but sugar is not a vitamin. You don't need sugar to survive, but you need vitamin to survive. It's something we cannot make. So I had one more question. I had one more things that I wanted to show you about this effect. We did. Let's see if I can show you.
Who actually started to force feed a goose.
So you
Then the Roman, they continued to do that.
fatty liver.
Now the French take
birds.
credit for the foie gras, but they were all doing the same thing. They were force feeding sugar or carbohydrate to birds, and that was creating a fatty liver. The credit to the American industry is actually to reinvent that industry, but instead of doing that with bird, they do it with us. And those beverage, those soda, are
Do you want
a
to be part of that
pleasant
chain?
feeding
No.
that you don't even
Yes.
notice, but that lead to exactly the same things to get a foie gras. And those beverages are just an amazing tool because you just enjoy it at the same time. You don't have any force feeding.
You know this was.
Anyway, so now we can chat if you want to chat.
I really need some